In this video, we're going to go through the basic concepts that's needed for the topic on kinematics. And the first thing we'll go through are the physical quantities that we're going to learn in this topic, mainly the distance versus displacement, speed versus velocity, and lastly, acceleration. Now let's revise on the basic of scalar versus vector quantity. Now you should know that scalar quantities are those quantities which only has magnitude. That means it has the size and there's no direction. You do not need to care about the direction. Whereas for vector quantities, they have both magnitude and direction. Okay, and for this chapter, let's start with the first physical quantity, distance. And because distance is like a length, and therefore the SI unit will be meters. Alright, and what do you mean by distance? For example, if you have town A and this is the long winding road to get to town B, so for distance, this is the path, this is the distance that you need to travel in order to get to town B, so that will be the distance. But there's another physical quantity here, which is displacement. Basically, displacement, the SI unit is the same, meters. It's just that it's distance traveled in a specific direction. In other words, you can actually think it of, you only care about the distance in a straight line from a starting point. In this case, the starting point is, let's say, from A to B. So if you just need to join A to B and the red color path in a straight line, that will be the displacement. Now let me give you another example. If you're standing at point A and then you go up north direction for 5 km to point B, and then you go to the east side for another 5 km at point C, and then you travel south for another 5 km to reach point D. Now if I were to ask you what is the total distance traveled, so you basically have to follow this physical path here, 5 plus 5 plus 5, so the total distance will be 15 kilometers. But if I were to ask you what is the displacement, you only care about the starting point and the ending point, and then you join it in a straight line. So it's basically going from A to D in one direct line, and that will be 5 kilometers to the east. Because direction is important for this case. Now let me give you another example of using displacement. Let's say you have a reference point at A and point B is 5 km to the right of A, the reference point, and point C is 2 km to the left of A. So now it really depends on where you fix the direction as positive. If I fix going to the right as positive, that means to say if you are standing here right now, the displacement is 0 because there's no distance between you and the reference point. And if you start to move to the right, there will be positive 1 km, 2 km, 3, 4, 5 km. And if you start to work backwards, so there will be 4 km, 3, 2, 1, 0. And if you go to the left of the reference point, there will be -1, -2, and -1 back to 0. So the negative here actually is a indication that it's moving to the left or opposite direction. Next, let's go to the next physical quantity, and we have speed. And as you learned previously, speed is equals to distance over time, and the definition will be rate of change of distance. Now for definition, it will be good if any formula that is over time, you can actually start your definition with the rate. So in this case, it's a rate of change of distance. So the SI unit, because distance is meters and time is in seconds, therefore the SI unit will be meter per second or meter s to the power -1. And another physical quantity that is similar to speed is your velocity. Velocity is basically speed in a specific direction, so the direction is important. So velocity will be displacement over time, or rather the rate of change of displacement. I have to use the word displacement, not distance, for velocity because this is vector quantity, velocity is a vector quantity. So for distance is a scalar quantity, your speed is a scalar quantity. Now let me show you another example. Let's say you are at point A and you move to the right and you fix right as positive. So if town B is 10 kilometers to the right of town A, and then you take a break there, and after that you make a U-turn and then go to town C, which is 4 kilometers away from B or to the left. So basically C is in between A and B along a straight line. So for this question, let's start with finding the distance for the whole journey. So the distance is the physical 10 kilometers plus the U-turn back 4 kilometers. So the total will be 14 kilometers. And if I have to ask you to find the displacement, and remember you only need to care about the starting point and the ending point, and it's along a straight line, so the displacement will just be 6 kilometers for this case. So I can also ask you to find the average speed. Now let's assume that, let's say you go to town B, you stay there for lunch, you wasted a few hours or whatever, or how many minutes. The total time taken, including those breaks or whatever, from A all the way to the final destination C, it takes 2 hours. So if I need to find the average speed, I will take the total distance, which is 14 kilometers, divided by the total time for the whole journey, including those times that you stop over for breaks or that. So that will be 14 divided by 2, 7 kilometers per hour. That's the average speed. And I can also ask you to find the average velocity, but you have to take note, if its average velocity is a vector quantity, I'll be using total displacement divided by the total time. So in this case, the displacement from starting point to ending point is 6 kilometers, and the time taken is still the same, 2 hours. That will be 3 kilometers per hour. The last physical quantity is your acceleration, and let's start with the definition, which is the rate of change of velocity. And take note, velocity is a vector quantity, so acceleration is a vector quantity also. Since the definition starts with the rate, and I say that you can actually recall the formula, is actually the change in velocity, which is v minus u over time, and the v will stands for final velocity. It's like the final speed after the acceleration in meter per second, and u will stands for the initial velocity. That means the beginning speed before the acceleration take place. Is also meter per second. So it's just a sign convention where v stands for final velocity and u stands for initial, and the time will be in seconds. Now, because the numerator is meter per second, which is your velocity, over seconds, so if you were to simplify it, it will be meter over second square, or you can write as meter s to the power of minus 2. So that will be the SI unit for acceleration. So as a summary, distance and speed belongs to a scalar quantity, and on the other hand, under vector quantity you have displacement, velocity and acceleration. So there's actually a pattern if you look at it. If you take distance divided by time, that will be your speed, and if you take displacement divided by time, that will give you the velocity, and if you take velocity divided by time, that will give you the acceleration. So these are the common physical quantity used in this chapter. And do not forget the formula for acceleration, which is very important. A equals to v minus u over t, where v stands for final velocity, u stands for initial velocity divided by the time.